Hi, this is Muhammad Saifuddin Chaudhry, and today I'm going to present here one of my project about AR heater controller with cloud computing and as well as with web applications. I'm going to show you this step by step. So in first step, what I have done here, I have to do the frequency response analysis in Python script so that I can get the appropriate value for KP, TI, and KC, which will stabilize my controller. Then this is my controller part where I have developed a PIController from scratch, and it will give the control signal to my air heater, which I am going to control. So here is my air heater, and I'm going to give 0 to 5 volt to control my air heater. And then I took my air heater feedback temperature into my C# application again through a filter. Which filter I have used here? I have used low pass filter. And then after getting this feedback temperature and after controlling the air heater, I will send my air heater temperature to OPC. And then from OPC I have used another application so that I will retrieve my data from OPC, and then I will log in my data to my Azure database, which is my cloud. So this is my storage in Azure database. And then finally I will retrieve my data from Azure database to my web applications, which has been done in C# ASP.NET. Now I'm going to show you something about in deep from first step to last step. This is my frequency response and stability analysis, where I have done some frequency response analysis. What is actually mean by frequency response analysis? It is a system which expresses how a sinusoidal signal, which already given frequency in the system input, is transferred through the system. So the basic difference between the input and output is a signal difference. The difference in the signal is the gain and the phase lagging. So here is one system where I have given input signal and then I'm getting some output signal, and then this in between this there is a dynamic system. In my case it is my air heater process. So here is two transfer functions which I have to derive before I'm coding in my Python script to start the analysis. So here two transfer function is here. One is for PIController and another is for AR heater process, which I got from my mathematical equations. I have done here Laplace transform, and then after doing this one I got my transfer function. So to represent my frequency response graphically, what I have used here, I have used board diagrams, which is very standard to represent graphical representation of frequency response. The acceptability range or margin is here 1.7 to 4 for gain margin and 30 degree to 45 degree for phase margin, which I will analyze in my Python program. So I can show you some of my Python program analysis result. Here is my result and step response feedback system, which I get from my Python script. And this is the value from my Python code, which as you have seen here, poles are all negative and imaginary, so it's existing the left side of imaginary axis. That means it is asymptotically stable, which is the main goal of this frequency analysis. So here if you see as the poles value, it's existing in the left side of my imaginary axis, so we can say that it's asymptotically stable system. I can show you now. I have set my k value and t value, which I got from my transfer function, and then the 0.85 and 20 I got from my plot and from my diagrams. I have chosen this one. I have increased some KP value to match my margin, as I have shown you, like it's 1.7 to 4 and 30 to 45 degree. So if I run this program, I will get this value, which is quite fine. As you have seen here, here is the value which I got and I have shown in my slide. And here is here is the pole and zero mapping. So as I've shown here, this its gain margin is 8.15 decibel and phase margin is 39.32, which is acceptable. Now I'm getting back to my presentation. Yes. Now I will describe something about my control system, how I'm controlling my air heater process. So this is my PIController here. As you see, this is my PIController in C# applications, and this is my air heater in hardware. And then I'm getting the feedback through my temperature sensors, and then I'm taking this feedback through a low pass filter, which is also inside my C# applications. And this is my set point, and which will subtract the error, and then it will give to the PIController. And then I have used the low pass filter inside my C# application as a separate class. As we know, like noise is a very high frequency signal, which is typically we don't want in our process, and low pass filters are used to remove those noise from measured signals. As I'm taking my feedback temperature, so I need some low pass filter so that it can remove the noise. And here is the equations which I have used inside my class, and the standard low pass filter equations. And like low pass filters, why we are using low pass filters so that it will make sure the low frequency signal only will pass and it will remove the high frequencies. And in another options, I didn't use this one although, but we can use this RC circuit also before giving the control signals to the air heater. So this is one of the options you can use. And here this is how I'm using my real air heater. Before that, I just want to show you this one in my here. Like if I set my value here 55, we'll check it will work or not. So as you see, my process value is increasing a little bit, and it's trying to reach 55, around the 55. Here we go, it's around now 50 to 58. It's going up and down since it's a air heater and some offset values there. So I'm controlling this air heater from my C# applications. Here as you see, this is my air heater controller, where I have used controller class, I have used low pass filter, I have used OPC so that I can log my data from these applications to OPC. I can send the data to OPC, and then I have used process for air heater for simulation. Actually, I have done the simulation before I start my work in air heater, and then this program and read analog temperature. So I'm reading the temperature as a feedback, and writing the control voltage to air heater. So this is one applications, and this is the applications as you see here, controller applications. And I have used this KP and TI value which I get from my frequency response and stability analysis. And this is my program. So here is my program for actually controlling the air heater. And then I have another program which will log the data to Azure. So here is my program. 1 second is here. Yes, this is my login applications. which I start. If I press the start login, then it will start login to my Azure. So if you want to see the latest value from my database, it's here. Um, as you see, I was given 50-degree temperature in my set point, so it was updating here. As you see the time is 5:22 now. It's a very recent value from my applications. So this is my second applications which I'm logging in Azure, and the third applications will be web applications where I will get the value from this Azure to my web applications. So this is my, yes, this is my third applications which is already running from here. So if I just stop this one and I can run my web application now, so it will retrieve the data from Azure. So as you see here, this is my website, this is my home page, and I have to log in, and other user also can log in from there. So this is my login informations, and I can log in here. So this is my data here, my email, my role here, and then I will go to process. I have several process: heating control, level control. If I put level control, so I can see some data which is already in my Azure database, and I can see my heating control since I'm doing my heating. Process now temperature sensor, show sensor data, and it will show me the latest value. So if I just refresh this one, and then I can see the latest value. So it's 5:24 now. It's the latest value is coming here, as I've given my set temperature 50, so it's going around the same. So actually this is the whole things for behind this project, how I have controlled my air heater, how I have chosen my KPKI value, and how I am giving those temperature data to my OPC, and how I'm retrieving those data from OPC, and I have logging my data into Azure, and from Azure the data will retrieved by my web applications. This is my web applications. So now I can get back. Hi, as this is a requirement of some of the project, like we need to deploy our program so that our web application, it will run inside the cloud, not from the local host. So to fulfill this requirement, we can deploy our web application into the Azure. So how we can do this one? I can show this one, how we can do this one. We need to go, this is my control system web application, and here this is my control system web application. I need to publish this one now. This is publish, and here, as I have created this one before, so I just need to publish this one here. It will take few seconds. Yeah, so now this is not from my local host, it's opened from Azure websites. Now I can log in my profile. So this is my ID and password. I can log in. This is my name, email, and my role. Here is the process. I have several process here: heating control, level control, RPM control. If I just put this RPM control, and then I can see my sensor data, RPM sensor data, and I have only one data, and this is my main process, heating process. From temperature sensors, I can see my sensor data here. As my system is already running, I can refresh my page, and then I can get my latest data. So here's my latest data. It's 13:39. Yeah, it's same time, and my application is running as you see in my background. this is the application from where I'm controlling my air heater, and this is the application from where I'm logging my data to Azure. So this is these two applications apart from my web applications. So this is my web application which I have already published. So here is my data. So everything is working fine here. This is my latest data. Yes, this is my latest data. It's coming from, it's running inside the Azure website. So this is the one of the requirement in industry. So I have implemented this deployment, web deployment in my project. To my presentation, maybe, where I have taken one video with. Now I'm going to present here the video which contains hardware, how I'm controlling my hardware here. So as you are seeing here in my display is this is my OPC server, and here I'm writing data from this application which is air heater controller, and then I'm taking this OPC data here and which one I'm logging in later in Azure. So as you see here, its setting temperature is 50 and my process value is working around 50. So here this is my air heater, it's on. You see this heating light is blinking to reach the set temperature. It's working now, so it's working fine. And as well as I can show you the Azure. In my Azure also the data is logging here, and from Azure database it's going to my final web application. This is my final web application. So I can just refresh it so that I will get the latest data from my real system. So here you go. So this is the whole things. So now as I have shown you here in my hardware video, I can actually show this one into. So this is my OPC server which is working very fine. As you are seeing here, this is my application is running from C#. As a controller applications, and another applications is another application is this one. So this is a distributed system. As we know, in DCS systems there are several computers work together. So in my systems I'm just trying to get all those things in from my computer, but it is possible to see and monitor this data, and as well as logging this data from different computer. So as you see here, like I'm logging here. This is my ID 845 844. This is my temperature 47.89 47.89 or something. It's updating like every second, as I have used the timer applications in my data logging app. So as you see here, it's in OPC I'm getting the data, the latest data, and as well as it is logging in my Azure also. Now I will go back to my presentations. Yeah, now I will talk a little bit about IoT and cybersecurity. So first, I want to talk about the issues and challenges. What are the issues of IoT and cybersecurity? This insufficient data protection by user might be overcome by using the data encryption. It is most important thing. And weak password and user ID protection shall be avoided. So we need to use some strong password, minimum 12 to 18 character, maybe with special character should be used with hidden character. And insecure interfacing of obviously shall be avoided. And there are some other challenges like vulnerability when third-party software are also can be an issue in a large network where many users uses the same network. And the thing is the data security for Azure SQL database cloud. What we can use, of course, we know this one. This REST API server support secures HTTPS, so we need to use that one. And for especially for like project like me, as I have done something here and I am logging my data into Azure and then I'm retrieving those data in my web application, so I have to have some authentication also. So in this project in SQL Server Authentications, I have used SQL authentication, which refers to the authentication of a user when connecting to Azure SQL database or Azure SQL managed instance using username and password. So every time I have to use my username and password to log in and to retrieving those data. And a server admin login with a username and password must be specified when the server is being created. So before using the creating the server, we need to take account all those things so that our data should be preserved and our data should not be hacked by hackers. So using these credentials, and server admin can authenticate also to any database on that server or instance as the database owner. So server admin also can choose like to whom he or she will give the authority to use. So that is how we can overcome hacking and those type of uncertainties. So in conclusion of my project, I just want to tell something about this one. Like IoT is more consumer oriented with applications like smart home automations, as well as an industrial application also. In this project, these IIoT topics are covered since OPC UA with MS Azure Cloud Service and these web applications have been used here. So this project is, I must need to say, is a very useful project for industry in a sense that distributed computer system has been followed here, because you can use 3, 4, 5 computers to log in, to monitor the data, to control the air heater, and to retrieve the data from Azure in your web applications. So it's a DCS system. So operator and other users also can monitor the data from web applications by using their individual logging ID, as I have shown my earlier presentation. So overall, I can see, and I can say also, like in the performance of PIController made in this project is very good and efficient. So I think you can try in this project to control some home automation system or any industrial system. So thank you very much for watching the video, and I hope it will help you. And if you need any help or any queries, so you can contact me with in my email. Thank you very much.